All right, welcome everyone to Open Source GIS from Field to Server, the Atlantic Edition. This is our second to last in this series, and I'm excited to demonstrate some software for you today. We are going to be running through a lot of materials, so I am just going to dive right in, but I do want to mention that I did open up the chat. I also opened up the Q&A, so you can drop your questions in there, drop questions in throughout the talk, that's fine. If I'm not able to answer them immediately, I'll answer them during the Q&A session at the end of the webinar. So we're going to go through a little bit of material. It's kind of the same with each of the webinars that I've been giving, but then we're going to do a little bit of a demo with some data that we're using from Moncton, New Brunswick. So looking forward to that. Let's dive right in. Okay, so a little bit about us. We are Luna Geospatial is a company that offers various services. We do consulting and training in everything open source GIS. So that includes QGIS, PostGIS, Geoserver, GeoNode, MerginMaps. We have a lot of expertise in remote sensing. We offer training and we offer professional support for open source GIS. We also have a software development division that works on things like WebGIS applications. We can build custom applications, dashboards, data portals, mobile first applications, and really anything that's database driven we can build. Lastly, we offer GIS servers. These are fully managed cloud-based servers. We manage everything, updates, upgrades. We handle backup, support, training, you name it, and they're all fully loaded with a whole bunch of open source GIS software for you, including Geoserver, Postgres, maybe GeoNode, MerginMap, Enterprise Edition, whatever you need. So our clients include a number of organizations across the country. We work with a number of archaeology companies, some CRMs, a number of universities, environmental organizations, an agricultural organization, and we do a bunch of different things for each. Some are using full open source GIS stacks. Others use just a little bit of the software, maybe just PostGIS to do some spatial data processing or as a backend to a web application, while others are using a full GIS stack, including QGIS and PostGIS, Geoserver, you name it. The intended audience for this webinar is anybody who is interested in but unfamiliar with open source GIS. And public or private organizations considering migrating to open source GIS. There'll be a lot of information provided that will sort of guide you down that path if that's something you're looking at. I will note that this is not an advanced course on all things open source GIS. If you are familiar with open source GIS, hopefully there's something that you're going to be able to get out of this that will be useful, but this is by no means a complete course on every piece of software that I'm going to be talking about today. If you're interested in this webinar, we do a lot of webinars. We try to do about one a month, but we are also going to be working a little bit more on putting out some other materials, some more videos, blog posts, things like this. We do not spam. We might send 1 or 2 or 3 emails a month, depending how many webinars we're hosting. Yeah, most people find them quite useful. They're usually just pointing you towards whatever's coming up in the coming month. So you can sign up at lunageo.com/newsletter to stay up to date with everything that we're doing. Also, all of our past webinars are on our website. So if you navigate over to lunageo.com/webinars, you'll be able to access all of our webinars that we've done so far. So there's a lot of useful things there. We also did a series called QGIS in the Wild that wrapped up at the end of 2022. We're hoping to maybe kick it back off again in 2023 at some point, but this was really just a webinar done by somebody who uses QGIS professionally in some way. So we got to speak to people who work for consultancies, people who do research, people who work for telecom companies. So it was really a good discussion with a bunch of different speakers. All right, so let's dive right into this. So what are some of the benefits of using open source GIS? Well, I have a top 10 list. Everybody likes a top 10 list. I think the first one that most people will mention is the cost saving without sacrificing functionality. A lot of people enjoy the fact that they can sort of install as much as they want on it, on as many number of computers as they want. They can put QGIS on everybody's computer. But one of the things that I always stress is that even though you're saving money, you're not sacrificing functionality. You're still able to do everything that you did with proprietary software, except now you're using open source software. So with that, of course, comes no license restrictions. So not only the actual software itself, but all the different functional components within the software. There's no floating license that has to go around in order for you to do some sort of like 3D analysis or terrain analysis. If you have the software installed, you can use all the tools within it. I've found that there's quicker and more frequent bug fixes. If there's something that's really impacting the functionality of the software, I've found that some of these bugs can be fixed quite quickly within weeks. I like that we can have organization-wide access to GIS, and the enterprise systems that we set up are really nice because we can really restrict access, or we can grant full access to some power users. So it really allows us to be quite granular with permissions. I like the ability to customize. I like the ability to take the software, combine a bunch of different tools, and create something that's going to be useful for a client. Open source GIS gives us that ability. There's also a large supportive user group. This is an international user group. People use things like QGIS all around the world. If you tap into any of the online forums or Stack Exchange or anything, you're going to and post a question about QGIS, I can almost guarantee you're going to have multiple answers. More tools. I always say that the biggest challenge of working with open source GIS is figuring out, not finding the tools to do the job, but figuring out which tools we want to use. Do we want to do all of this in Python? Do we want to use the desktop tools to do this? Do we want to do it all within spatial SQL? Do we want to do some combination of all of the above? Interoperability is key. Even though you're moving or you've moved to open source GIS, you still have to be able to share your files with people who may be using proprietary GIS. That is honestly never a problem. You're always able to export things into a format that will open pretty much in any piece of GIS software. You're even able to export things into different types of CAD formats and be able to open them up in CAD software. Extensibility is key, and this is something we do quite a bit at LunaGeo. We might build a custom plugin that's used to allow a user to do things like automatically create a project within a database by clicking a button. That can be done. We can build upon something like QGIS and create our own custom tools. And enterprise features. We set up enterprise GIS solutions, so we can set something up that really, as I said before, we can be quite granular with permissions. We can set something up that's very complicated and have multiple roles throughout your organization if you wish. We can set something up quite easy too that can have just like an editor or a read-only role. We really have a lot of flexibility there. And when you can combine the different components, things like PostGIS and QGIS, you have access to a lot of enterprise features, things like saving default symbology into your database, saving projects centrally within your database. There's really a lot of neat features there. And then your big bonus benefit here is documentation and other resources. There is a ton of documentation. I think it's the biggest myth about open source GIS that's out there. If you navigate to something like the QGIS webpage, you'll see that there are a ton of resources there. There's the training manual, there's the QGIS manual, there's the Python developers manual, things like this. There's a ton out there. And likewise, if you go over to something like PostGIS, you'll find a similar number of resources. Geoserver, same things. All of these really big, mature open source software, pieces of open source software have a ton of documentation. And then there's other resources too. There's books published on all of these software. There's training courses online. We provide training courses as well. There's just a ton of resources out there if you need them. So what does a typical open source GIS stack look like? We start with an Ubuntu server. It's one of the top flavors of Linux to run the GIS server. We use QGIS, which is a powerful feature-rich desktop GIS. Postgres, which is a top relational database management system. It's comparable to something like SQL Server or Oracle or DB2. And then to make things spatial, we use PostGIS. PostGIS is the spatial extension for Postgres. It allows you to have access to hundreds and hundreds of spatial functions and data types and all this other wonderful stuff. Now, Geoservers are means of sharing geospatial data on the web. So we can share raster and vector data on the web through Geoserver in a number of different formats. We'll get into that in a little bit. And MerginMaps. MerginMaps is something that we've been using quite a bit lately. We're a partner with MerginMaps, and we help set up MerginMaps Enterprise Edition or just custom apps that you may need. There's also a sync tool that allows you to sync your data from MerginMaps directly into your database. But this allows you to do mobile data collection, so you can collect points, lines, and polygons in the field. Now, the last thing we often build into an open source stack is a custom WebGIS application. So we have something that we call our LunaMap platform, which is really a boilerplate WebGIS application that we can customize to a client's needs. So this allows you to do stuff like load layers, turn them on and off, have base maps, be able to see all your vector and raster data on the web, custom printouts, identify tool. You can search and zoom something like a parcel data set and find a location. So it's a lot of neat sort of basic tools that you need to be able to interact with your geospatial data. So what does this actually look like? Well, when we set this up, we start with Postgres and PostGIS. We set up all your users, we load all your vector data into here, and we share out what we need to Geoserver. Also with Geoserver, we load all of your raster data. So if you have a ton of aerial photos, DTMs, DSMs, whatever you want to share, we can share that through Geoserver. Next, the most likely output for this is serving something to the web. So we can either use something like GeoNode, which is like a content management system for spatial data, or we can build some sort of custom web GIS with leaflet or open layers. This is also a nice way with Geoserver, we can share data out to clients. So if you're loading all of your data into Postgres, you're editing a whole bunch of stuff with QGIS, you're developing some data sets, at some point you can share that out to your clients. So instead of sending them like a zip file of some shape files, you can share the data out through Geoserver, and they can have either real-time access to the data as it's being updated and created, or you can do fun stuff like in the database, create something called a materialized view and have sort of versions of your data that you put out to Geoserver and there to the clients and to the world. Next, we connect QGIS to Geoserver and Postgres. So in QGIS, we can load all of your aerial photos, any rasters that you're loading into the application. We can load that from Geoserver. And with your database, we have a direct database connection. Now, when we're using QGIS, of course, we're still using our file system. If you're doing something like, raster analysis and you need access to a massive DEM, you're still going to connect directly to your file system and use it. But this is going to keep your staff happy. So now your staff through QGIS are going to be able to have access to everything that you've shared through Geoserver and all of your vector data that lives within Postgres. Next comes MerginMaps. If you're going to be doing any mobile data collection, MerginMaps is the app for you. This, again, keeps your staff happy because they're now able to take QGIS into the field with them by using the MerginMaps apps, which work on iOS and Android. And then we have a little secret weapon here, MerginDB Sync. This allows us to sync your data, all the data that you collect in the field. You can sync it directly into your database. So if you're going to be collecting something like, hazard trees in the field, you can then sync those data directly into your database. And then anybody who has access to the database, either outside through a web app, to a client via Geoserver, or one of your internal staff through QGIS, they'll be able to have access to all the data that was collected in the field. So this is our stack. These are all the pieces that fit together to give you a full GIS solution. So what about open source GIS implementation? How do we go about it? Well, there's 6 stages we go through, typically with a client. The first is configuring the server. So we have to choose what software we're actually going to be putting in here. Are we putting Geoserver and Postgres? That's kind of our basic starting point. Are we going to be doing MerginMaps? Are we installing GeoNode? Are we installing a custom web GIS? Next, we do the database development. And this is a little bit more of a complex phase where we have to design the schemas, tables, trigger functions, all the other objects that are going to live within the database. But even bigger than that, we also have to design the permission system. So this is where we go through with a client and say, okay, you have all this data. Who should have access to it? Who should be able to edit it? Do we want anyone to be able to edit this data set? So we go data set by data set, schema by schema, and we decide who should have access to the data within your organization. Next, we work on data and workflow migration. To migrate the vector data, this is really just loading it into Postgres into the designated schemas. Think of schemas as like folders. I'll show you that in a few minutes. And we can also migrate our raster data to Geoserver. So this is a process where we optimize the imagery and then we load it onto Geoserver. Next, we have to think about workflows. Maybe you've been using proprietary GIS and you're migrating towards open source GIS. We work through your workflows. We figure out what you're doing, and we try to replicate as best as we can those workflows within QGIS or directly within the database if we can. Likewise, if you have any ETL scripts, if you're using any Python scripts, let's say to pull some data off the web and load it into your current solution, we will do our best to replicate those scripts as well. There might even be an easier way of doing it through something like a foreign data wrapper in the database, which allows you to connect to any other database or even an API. And there's a whole bunch of other things that foreign data wrappers can do. So training and documentation, this is important. I always say that it's fine to set up an open source GIS server. It's amazing if people can sort of migrate away from proprietary software and use open source GIS, but they need training. So we provide a long list of training from like intro and advanced QGIS, PostGIS and QGIS in an enterprise environment will teach you how to use a lot of the enterprise features within QGIS. To interact with your database, intro to Geoserver, intro to MerginMaps, but we also provide sysadmin training. So if you do have somebody on staff who does your current system administration, we provide them with the training they need to be able to use the GIS server. And the bottom line here is that we also provide workflow documentation. So as we sort of worked out your workflows in the previous step, this is where we'll actually write out how to do your various workflows. I do this usually in 2 ways. I might write it. If writing it is not really that important, I will actually do screen captures. So kind of like what you're watching right now. And I will record the video and I will provide those videos to the client. Then we go live, and this is where all of your staff get access to the database and the GIS. They've all had their training and they can do wonderful GIS-y things. But after that, the thing is we can't just leave it. We provide that ongoing support. So with all of our servers, it comes with a little bit of support, but you can add on to that if you want. We have a sort of pay-as-you-go method as we for support. And we provide support through email or virtual meetings. But that ongoing support is important because as problems come up, it's nice to solve them so that you continue your work. All right, so let's talk about some of the software that we use. For desktop software, of course, our starting point is QGIS. QGIS is a powerful cartography and spatial data management tools, tons of tools, hundreds of tools within the processing toolbox. There's a great QGIS processing framework. You're able to do things like open up the graphic modeler and string all these tools together and create these sort of customized tools. You can do 2D and 3D analysis within QGIS without any restrictions. There's no extra licensing you need to do anything. You can create, edit, manage, and export data in pretty much whatever format you could imagine. There's a great QGIS plugin market. I did a webinar last year on QGIS plugins, which is to this day our most popular webinar that I've done. It's on our YouTube channel, and there's just a ton of plugins. I think there's like over 900 now in QGIS 3. You can also use, if you're a more advanced user, you can use things like Python or R, or my personal favorite, spatial SQL, to do any analysis within QGIS. There's also you can create custom tools, as I said, within the graphic modeler. And there's always new things coming out within QGIS. I think the big one that people are excited about now is that there's additional support for the point cloud processing, and that's coming soon. Another one, and again, don't judge it by its logo, but Saga GIS is actually an impressive piece of software as well. It's pretty much a full remote sensing software. It has a lot of tools, full GIS tools. It's fully integrated within the QGIS processing toolbox. So you can actually use Saga tools, not within this environment, but you could use it within the QGIS environment. You can do both raster and vector analysis. It's easy and effective implementation of spatial algorithms. I've used it a lot over the years. I've sort of found tools that I needed, and I've done things in here when required. It's just nice to have in your toolbox to know that you can tap into some of these tools and use them if and when required. It's a nice modular framework, so all the tools are kind of grouped together in different modules. You can do things like geostatistics, classification of satellite imagery, and so on. Some of the modules include terrain analysis, simulation, image classification, geostats, and hydro algorithms. Another one is GRASS, very similar to Saga in that it's fully integrated within QGIS. There are a ton of modules in GRASS. It's been around for many, many years. There's like 350 now to do both raster and vector analysis. All the tools work within QGIS if it's properly integrated. And as I said, vector and raster processing. There's some specialized remote sensing tools that are quite handy. And some of the notable modules include things like network analysis and LiDAR processing tools. And as I said, fully integrated within QGIS. GDAL, we've all used GDAL, whether or not you know it. GDAL is the most widely used geospatial library. It is used for image processing. There's a command line interface that's available by using a tool called the OzGeo4W shell. If you are a Windows user, you will find that. Within in your system once you install QGIS. And that'll give you an access to the command line tools. I do most of my processing on the command line when I'm using GDAL. If I'm processing something like imagery, I'll do it there as a Python script or straight up right on the command line. It's also available in QGIS, but I should add it's used pretty much in every GIS software. Really, whatever you're using, whether you're using ArcGIS, whatever flavor, QGIS, everything, it has some sort of GDAL support within it, anytime you're processing imagery, especially. And as I said, fully integrated within QGIS. So one of the nice things you can see here is this is right from the QGIS processing panel. You can do your analysis using some of the sort of native QGIS tools, but you'll also have access to all of these GDAL specific tools, which are really handy, especially for things like if you're processing something like a DEM, if you want to do terrain analysis, all these tools are available within QGIS. All right, PDAL is kind of like GDAL. It's a point data abstraction library, and it translates and manipulates point cloud data. You can create pipelines with readers, filters, writers, and process and change and modify point cloud data. You're able to, of course, process raw LiDAR point clouds using it and create things like digital surface models or digital terrain models. One thing that's nice is it's now integrated within QGIS in the latest release. So some new tools have been created. If you're using the long-term release, you won't have it available. But if you do try the latest and greatest version of QGIS, you will find those tools in there. All right, so what are we doing on the server? Well, as I said in one of my opening slides, is that the core of our GIS server is always Postgres and PostGIS that allows us to have that spatial database. Postgres has been in development since 1996. PostGIS since 2001. This is a very mature piece of software, or pieces of software. And with PostGIS, we do have access to hundreds, as I said, spatial functions, data types, and so on. But one of the things that's nice is that by installing our software, our data within a relational database, we can do things like we have simplified backups and restorations. We can load all of your data within the database, which is quite nice. And then backup, restore, restorations are quite easy. There's a complex permission system. We can get quite granular. We can grant somebody access to a table, to a schema. We can even control which columns a user is able to edit within a specific table. So we can say, sure, you can edit everything, but you can't change the status field, or you can't change the ID field of the data set. Another nice thing we can do with a relational database management system is we can create what's called audit tables. So every time we insert a row or update a table or do anything, we can trigger a function that writes something to another table. This is called an audit table. So we're then able to keep track of all the changes that happen within our database. And we can even use those to roll back any accidental deletions or modifications. Another thing that I work a lot on are developing trigger functions, especially spatial trigger functions. This allows us to do things like calculate area, perimeter, distance to the nearest road, distance to the nearest watercourse, and so on. Now, Postgres is very well integrated within QGIS. We can do things like save default symbology to the database. We can have full database management via the database manager within QGIS. We can run complex queries with the database manager. We can load query layers. We can use the database layers with native QGIS tools. This is really cool because you can load a layer into QGIS, run something like the buffer tool, and save the result directly within the database. Another nice thing, as I said earlier, was we can save QGIS projects directly in the database. This allows us to centralize things like a default base map that can be used within your organization. So any user can load it, and it'll load all the layers, all the symbology will be correct, and everyone will have this common map that they'll have access to. We can manage authentication through QGIS. So any restrictions, of course, you place on the database, like so-and-so can't edit this table, that will obviously be reflected within QGIS. And then we can also integrate with a variety of plugins within QGIS, within QGIS. So PostGIS will actually work in things like, there's a plugin that I love called the Discovery plugin, and it allows you to simply do search and zoom, but you can set up a custom search. So for something like a parcel data set, you could search the roll number or the street address. If you're dealing with a very large and complex watercourse database, you can use the Discovery plugin to easily search that watercourse database and find a specific tributary. What about Geoserver? As I mentioned, Geoserver is quite a mature piece of software, been around since about 2001, and it permits sharing and editing of geospatial data over the internet. You have the ability to connect to a variety of different data sources, including vector, raster. You can even connect to remote servers and databases. Servers serves data as web services, vector data, raster data, and so on. And you can install a lot of extensions. One of the things that's nice about QGIS is that you can, if out of the box there's some functionality that isn't there, there may be an extension that gives you that ability. So if you want to connect to something like Oracle or SQL Server, you could install a connection to be able to do that. There's other OGC compliant servers out there, including Map Server and QGIS Server, but we typically at LunaGeo stick with Geoserver whenever possible. All right, WebGIS. Well, Leaflet has been around for a while, and Leaflet is a really powerful little JavaScript library that's used to build web mapping applications. It's actually integrated within QGIS. There's a really neat plugin called QGIS to Web that allows you to export your current map project to either Leaflet or Mapbox or Open Layers. Very neat thing. But for more complex web applications that you're trying to build, especially if you're trying to do a lot on the client side, in terms of developing tools and things, Open Layers is another JavaScript library that's quite useful. First released in 2006. It's a JavaScript library. It supports OGC standard formats, so your WMS, your WFS, and so on, and it has built-in basic and advanced tools. So things like vector tile support is well integrated within this library. Another application that we are starting to use a lot more at LunaGeo is GeoNode to build a sort of open data portal with this application. So GeoNode is technically an open source geospatial content management system. It simplifies user management and data access rules. It allows you to add data to this application and share it out either privately or publicly. And it allows you to do things like full text search through all of your data, maps, and document metadata. So if you're looking for something specific, you can find it quite easily using this application. There's a great data, map, and document catalog. So not only can you upload spatial layers, raster and vector data, and then create maps with those data, you can also upload documents. So think if you're going to have some sort of report that's associated with a data set, that can be uploaded to GeoNode as well. The metadata catalog is key here. You're able to fill in a variety of different fields to create a standardized metadata catalog for your geospatial data. You can also download data in multiple formats. So again, like I said, this is a way of sharing geospatial data. So once you have GeoNode set up, people are able to either connect to this through something like a WMS service, but they can also go in and download the data. So if they want to download it as a geo package or a shape file, they can do that. There's an integrated WebGIS that allows you to load a number of layers, style the layers, toggle the layers on and off. And there's also this GeoStories extension that allows you to sort of tell a story with geospatial data. You can have a number of maps and different headings and so on. One of the things I really like about GeoNode is that it's well integrated within QGIS. It's actually available in the browser menu, which you see here. And with that, you're able to connect to your GeoNode. Now, if you have an authenticated GeoNode, so if it's protected with the username and password, you can add that as well, and then connect to the GeoNode and start loading data that you've shared directly within QGIS. What about custom WebGIS? This is something we do quite a bit, and this is an application that we built for a client. We can build applications that pretty much does everything we need. We can toggle layers. It supports WMS, WMTS, WFS, vector tiles, point stacking, whatever you really need. We can have a base map switcher. We can switch between your own optimized and shared aerial photos, or we can tap into any service on the web. Easy search and zoom. We can click on things and identify, which you see right here in this screenshot. We can filter features via a search line. We can create custom print layouts. We have an integrated GPS tool. So if you log in, you gain access to a GPS tool where you can collect point data. This is kind of handy if you're sort of walking down through, through a trail and you find that there's a broken, bridge. You can easily use this tool to mark that on the map and then deal with it when you get back to the office. We have the ability with this application, because we're building this custom, we can create both public and private tools. So if there's certain tools, like if you don't want the public to have access to your print tool, we just turn the print tool off and they don't have access to it. Likewise, we can do the same thing with layers. We can have a group of layers that are just private, and we can turn them off. And you have to be authenticated in order to actually see those layers. So of course, we have a fairly complex login user management with multiple roles that we can establish for your organization. We can also do things like we have a share button. So if you want to share your current location with all the layers that you have on, you can do that. Some other basic tools like measurement tools. But one of the things I like most about this is that the reason why this is kind of like a boilerplate application is that we can create custom tools. So if you want your own version of this map, but you want a tool that does something like, okay, well, when I click on an intersection, I want to select a certain radius, and I want to select all the parcels within that radius, and I want to turn it into a CSV file and export it from the application. We can build something that does that. And the list honestly goes on. There's no limits kind of to what we can build with these types of applications. All right, what about mobile data collection? Let's dive into this really quickly. So if we're talking about MerginMaps, this is our preferred mobile data collection platform. You can do field data collection. It's fully integrated within QGIS. I shouldn't even say integrated, it's dependent upon QGIS. You can view your data and location on the map. You can capture points, lines, and areas and photos. You can scan barcodes, yes, barcodes and QR codes with this application. And you can sync data with the press of one button, so there's no cables. So you don't have to bring your phone back and plug it in and sync it back to your app. You can simply do all of that within the application. You can store and version your data safely in the cloud. I'll show you when I give you a little bit of a demo of how this works. And you can have unlimited projects, unlimited seats with this application. The nice thing is, what I said before, is that we can sync data back to your enterprise Postgres or PostGIS server. And the enterprise edition is coming soon. It's actually out now. I should update that slide, but it is available now. And as a Mergin partner, we're able to offer that and spin it up on a Canadian-based server. So if you're interested in doing more mobile data collection, you can definitely be in touch, and we can guide you to a solution. All right, so let's do a little demo now. Let's talk about show you some of the software that we've actually been talking about. So we're going to configure an open source GIS server. This isn't a complete server. We just grabbed a few layers to do this demo for you. We are using data from Moncton, New Brunswick. We downloaded some data from their open data portal called Open Data Moncton, which is available at open.moncton.ca. And of course, to keep the lawyers happy, LunaGeo has received no endorsement, support, or sponsorship from the city of Moncton with regards to the public data used in any software or services promoted in this webinar, implied or otherwise. We simply took some open data, and we're going to show you how it looks and how the look and feel of those data within these open source GIS software. Okay, so the first stage, as I said, or one of the first stages, once we have a server set up, is migrating your data to Postgres. And we go through this process of configuring the database structure. We load vector data via the database manager. We create the default symbology. We create projects in the database. We create trigger functions. I'll show you sort of how this works. Is that if we move over to QGIS right now, I have a database created that I created for Moncton. If I go into the database manager right now, I'm going to show you this demo database that I created, and it has a number of different schemas. So think of a schema as kind of like a folder. So in this one called boundaries, I have the Moncton municipal boundaries, but I also have the wards here. And when we click on one of these, within the database manager, we're able to see all the different fields and the data type. We're able to see if there's any constraints on that layer, and we're actually also able to see our privileges. So as an admin user, I'm logged in as an admin user, so I'm able to do everything: select, insert, update, delete. For a small layer like this, I don't recommend clicking on this if you have like 10,000 different rows. You can see the table. You can also see a preview of the layer with the default symbology established. So the database manager is quite handy. We can do things like create new schemas. We can also edit the table if we want. So if we wanted to add a new field to a table, we can add that new column. We can edit existing columns. We can rename them. We can do pretty much whatever we want. But for the tables, we have full table management, full schema management, and we can connect to a number of different databases. So once we have all of this within the database, we can create and save our projects centrally. So I created a very basic sort of base map for Moncton, and now I'm loading all of the data from the PostGIS server. I've grouped together a bunch of my layers, so I have all the transportation layers. I can turn these off. I can even turn off our base map if you just want to see the data that we're pulling in from PostGIS. So it's quite responsive. It's quick. It's even though we're dealing with a remote server, and here I am, I'm connecting with a normal internet connection, nothing too fancy. I don't have a gigabit connection or anything, but we're able to connect to our remote server, and it's quite quick. We'll turn our base map back on. And we can, of course, toggle our layers on and off. So I can turn things like the buildings on if I want. Looks a lot better if I turn off the base map. And I have buildings, I have water, I have parks, and I can turn on all of these layers. I even have the fire hydrants, the 3,000 plus fire hydrants that can be turned on quite quickly this way. So it's fairly zippy. I want to show you something I can do with styles. So we talked about saving the symbology to PostGIS. This is a big part of what we do when we're setting up layers for clients or setting up maps for clients. Is we'll go in and we'll say, okay, what do you want? Well, okay, we'd like the ward boundaries to be green. That's fine. But you might want them to, you might want another color. You might want to change it. You might want to have different versions of the layer. So let's say, for argument's sake, we actually want one that has an orange line. So we've pressed apply and we've created this one. I'm going to turn off I'm doing the main boundary here. The main municipal boundary. So now I've turned it into orange. It was green before, now it's orange. If I was to load the layer again from boundaries, that's just our municipal boundary. If I loaded this in again, you're going to see that the one I loaded is green. That's because that's the default style, and that's saved within the public schema of the database. We actually have a table called layer styles, and that's where all of our layer styles are saved, and they're loaded into QGIS from that table. So I have this one here, but I've now, I'm going to remove the green one and just restore the orange one that I just created. If I want to save this style as well, I can go into properties and I can go to here and I can save style. And I can say, I want to save it within the database and I want to call this boundary orange, and I'm saving this into the database and press OK. Now what I have is, if I go into properties, I can do things like this. I can do load style. Now I have access to two for this layer. I have the Moncton municipal boundary, which is our default, and then we have this one. So now I could switch to the next one, press OK, and we're back to that same style I had before. Likewise, I can go into properties and I can say load style, and I can choose this next one, the orange one, and I can load that style. So what's nice about this is that because this is all stored within a table in the database, we can control who has access to those data. So we can control if you're actually able to edit the styles that are used within the organization. Now you can always load the layers. You can always load the layers and style them differently for a map if you want. But by default, when the layers load, just like I'll do now, if I load this layer, it's automatically being loaded as that green with the green outline because that's the default symbology. Okay, the other thing that I mentioned is that we can save maps within the database, and that's right here, this little QGIS icon that you see, and it's saved within a table within the database as well. But we can do that simply by going to project, save to, Postgres, and then it'll show us our available connections. We only have one, this Luna Geo demo. I do have a schema called maps, and I could call this if I wanted Moncton 2, and if I did that, this would save into this schema, and I can refresh, And now I have two maps here. I have my original Moncton base map, which you saw when we first loaded, and it had a bunch of layers loaded in the base map. But I also have this other one, which is the exact same layers, but it's called Moncton 2. And I had the base map turned off and everything. So now we're loading the other layer. So we can save all of these within a specific schema. You can save the map within individual schemas. If you have something like an engineering or a planning department, they can save maps within their own schemas with their data. So it's really quite flexible how we do this. All right, so now once we have all our data sitting in a spatial database, what can we do? The thing that I love the most, which is a spatial SQL query. So once we have the data, and one of the most powerful features of loading something into a database is that now you can use SQL to query it. So you can ask questions like, how many parks are there in each ward in Moncton? So I wrote a fairly straightforward query that just uses a left join to connect the parks table with the ward number or the ward table. And this is what it looks like when we run it in QGIS. The important part here is that left join, where we use a couple of spatial functions. We use the st_intersects and function to look at the intersection between the two geometries, the wards and the parks. But when I ran this the first time, I realized that we were double counting some parks because some parks cross the boundaries between wards. So I simply added the st_centroid function on the park's geometry and said, well, if the centroid of the park lands within a ward, we'll just say it's that ward's park. Now, of course, we do a more complex query here and actually clip the farms of the parks and count them that way, but this adds up to the total number of parks within the municipality, so it works great. Now, what if we want to ask a little bit more of a more complex question? So what's the total area of parks within each ward in Moncton? So again, I did the same thing. This is where it gets a little, well, you probably should clip the polygons, like actually run an intersection on the polygons and say, well, if the park sort of half crosses into one ward into another, we really should divide it. But I just went with centroid just to keep this easy for this demo and said, if the centroid's in a certain ward, count that park as being within that ward. But we did a little bit more magic here. The magic happens right here, is that instead of simply counting the number of parks that were in there, we're stringing together a whole bunch of different functions. We're using the round function, we're using the aggregate function sum, and we're calculating the area of the geometry of parks with the st area. That's a PostGIS function. Next, we're doing something called a cast, and we're just changing the data type to numeric so that we can use this round function. We're dividing it by 10,000, and we're giving it 2 decimal places, and we're going to call that field hectares. So when we do this, we're able to calculate easy within 0.083 seconds the total area of parks within each ward within the city. Neat stuff. This is really the tip of the iceberg of what you can do with spatial SQL, but you can at least see from these examples that we can string together a bunch of different functions, native Postgres functions alongside the spatial functions, and ask some very complex questions within the database. All right, so what about raster data? We have all our vector data loaded, but there's a whole stack of aerial photos. They've some Mr. SIDS, ECWs. That's always the start of a bad day for me. And we want to put them onto the database. The first thing that we always do is that we optimize the raster data using GDAL, and we load it. Into Geoserver. So really just upload it to the server and then publish it through Geoserver. We serve and cache the imagery with Geoserver in something called GeoWebCache, which is integrated into Geoserver now. And then we can consume the web services via QGIS. All right, so let me give you a little demo of how this works. I'll give you a demo from the endpoint perspective, right? So now that we have our layers loaded, we're able to run, oops. Boom. All right. So we're able to connect to our WMTS connection, and we're able to filter by Moncton, and we're able to load this. And now this is a WMTS connection. So this is loading directly from the Geoserver. This is just a data set, the only one that they had available for downloading in terms of rasters. Looks like an old sort of aerial photo, but we can zoom in quite quickly and load our data and see this aerial photo. So this didn't take long to process. We just optimized the imagery and loaded it in, but this is pretty much the process we go through with each. Now on the Geoserver side, when we are connected, and I'm guessing that I'm logged out of here, but we'll try again. So now this is the web interface for Geoserver. It allows you to manage all of your data. We have our layers in here. We can preview our layers. We have a number of different layers that I've used for all the different webinars that I've been doing. But here's our Moncton aerial. So we can preview it in open layers. And this is, again, the same layer that we just saw. We're able to have access to it and can view it within this screen. So one of the nice things we can do too is we can cache the layers. So if I'm going to cache the Moncton layer, I can see right now the disk space that I've used is 677.3 megabytes. I'll show you something cool with this. So let's load up our Moncton base map right now. All right, so now I'm going to switch over to the aerial photo, just take off the OpenStreetMaps, and I can zoom in. So I can zoom into something like Mapleton Park. I have a couple of bookmarks that I put into here. So I can zoom into this area and take a look around. Now, one of the things you'll notice is that a lot of the tiles, it's quite fast to load, right? As I'm moving things around, but it takes a second. You see it's taking a second to load that tile. That's because it's building the cache. So we've set the server right now to actually build the cache. So you see it's at 677. When I press refresh, it's at 691. As I move around a little bit more, these tiles are loading. If I come back and press refresh again, we're at 696. So it's actually building cache as we use it. The nice thing about that, and I'm sure you can sort of figure out, think of some of the benefits of that, is areas that are most commonly used will be, so if you're thinking like, I don't know, Riverfront Park, these areas will be cached and it'll be really quick to zoom in and out, and you're not going to have to store cache for the entire image on the server and fill up the server with it. It'll just store the most important areas. So other areas that you may not sort of go into, like random sort of, you know, rural areas on the outskirts, there's no reason to, let's say, cache this area. Now, the only trade-off of that is that as you come in to work in those areas, if all of a sudden you need to use the aerial here, it's going to take that extra, 3 seconds to load for the first time until it caches the tiles in the area. The other thing you can do too, so again, as I've been messing around with this, let's see what we're up to. We're up to 747. It's nice with Geoservers, you can set the disk quota. So you can set the cache quota for Geoserver and say, okay, we want to only have 25 gigs of cache and have some sort of policy that will dump tiles. So that's pretty much how we load aerial photos, optimize them, load them, serve as many as we want. Okay, let's get into some fun stuff quickly before we run out of time today. So we're going to I'm going to show you how MerginMaps is set up. We're going to do a hydrant inspection. So first thing we're going to do is just build a QGIS project. There are 3,401 fire hydrants in the Moncton data set that's available through their open data portal. We're going to convert the hydrant data from PostGIS and just convert it into a geo package format and just store that locally as a project. And we're going to create a project that just has OSM and the hydrant points. City boundary is optional if you want to add that to the project. And then step 2, we're going to create the hydrant inspection fields for 15 questions. So the questions are the inspection date, time, the inspector name, is fire hydrant accessible, are there leaks, are there cracks in the hydrant barrel, verify the tightness of the outlets, inspect outlet threads for wear, and so on. The list goes on, and then there's a couple of text fields and sort of what's the overall condition, where there'll be a drop down. So we want to add all 15 of these fields to the existing data set that we just made a copy of. So we add these fields with the appropriate data type. So you see I have a few integers here. They're going to be used for like a pick list. to store data from a pick list. We have a couple of Booleans where we're going to have sort of a checkbox, a true false here. And then we have a few more integers for things like overall condition and service. If service is needed, that's going to be a drop down. And then a couple of text fields where we can add comments or specify the type of service that's required for this table. Next, we want to create an attribute form. If you haven't created attribute forms within QGIS, I often say that you have not lived yet, because you can create quite complex forms to collect your attribute data as you're digitizing. I like creating a tabbed interface. I like to be using the tabs to sort of divide data between different views within the form. I also will add aliases for all of our questions. So even though the field is called Q6 tightness, I don't want to have that be the question. I want to have it say verify tightness of outlets. So that is the alias that I'm going to use for that field. And we can add a number of different widgets for things like drop downs, date pickers, and you can see that I have actual checkboxes that we can use in this form as well. It just makes the process of entering data easier, but it also helps maintain the integrity of your data as you're inserting it. So step 3 is creating the MerginMaps projects. This is easy. So we package the project for MerginMaps using the MerginMaps extension, and that's just here within QGIS. We have this extension where we can convert any projects into a MerginMap application. We sync the application with MerginMaps, so any changes we've made, we can sync to the app. And we then sync it to a mobile app. So we just open up our app, and as long as we're connected to the same MerginMaps connection, we bring down the data, and then we survey. And the first step is really just clicking that button and clicking package current QGIS project. So as long as we've created a new project, we can click this button and just turn it into a MerginMaps project. So the first step is really just choosing, when you're packaging it, is choosing which layers you're going to package for the app. Next, we're going to say where we're going to save the data on our file system. And then we're going to press go, and it's going to create the project and sync it up to the cloud automatically. So on the desktop view, if you open it up, and I can show you what this looks like here too, is that when we have our MerginMap app created, you're going to have a little folder underneath MerginMaps within the browser. And if you click on this, I'm going to press no to save this. This will open up our app. And you can see this is just all 3,000 plus fire hydrants, plus a couple of ones that are green on the map. And I'll show you in a sec what those are. Now on the Android app, this is the view of Android, but you can of course use this in iOS as well. You're going to see the exact same data, same styles, same symbology, same forms, except the difference on the mobile app is that you're going to be able to collect data while you're in the field. So the forms that you saw on desktop look like this. You have your inspection form, which has all the fields, and you have all the attributes. So I did something special with the attribute fields. So if I turn on an editing session and identify one of these on the desktop, we have our whole form here, and we can check things and turn things on and off. But I also added the attribute data. One of the things I didn't want is I didn't want any users to come in and actually modify any of the attribute data, because that would kind of screw things up. Because if we're then going to bring this inspection data back into the database and connect, say, hydrant ID 1961 with the actual record that's in our database to say, when was the last time it was inspected? We're going to create problems here, right? If that value is changed, they will no longer link. So we have two tabs here. We have the inspection and we have the attributes that can't really be modified. Okay, so what does this then look like on the app? So the inspection tab looks exactly the same. I actually kind of like it on the mobile app because it has these little switchers that switch back and forth to, set it to true or to false. The drop-down menus look quite sleek on the mobile app as well. And I also like the date picker. It looks quite nice. And then the attribute data can also be seen on the app, and you will not be able to modify those values within the mobile app. So after you've done some work and you've saved some data, if you go back to the MerginMaps website, log into your account and look at the data that you've created, I've only made 2 changes. You saw those 2 points that I modified on the map, but it saves each time you sync, it'll save those changes to the app itself. So if I was going to come in and say, I'm going to come in here really quickly and I'm going to add a date on here, that will change the style to being green is what I have it set to. I don't really need to change anything else, but I'll just press OK. I've now made a change. I'm going to select away. Now this is green because I've set a date to it, but I've made a change now. Now I have 3 values. All I have to do is press sync. It'll come up. It'll say, are you sure you want to change this? You have updated 1. I'll say yes. I'm going to run this sync. It's syncing to the cloud. It says everything's good. Now, if I go to MerginMaps and then click on our application that we just created and click on history, I can see that now there's a new version. I just made some changes here. If you want to roll back, you're able to do that. You can download a previous version of the data. If you realize that you had some summer student that really screwed up and collected all wrong data, you can eliminate the changes that they've made and restore back to a certain version. It's really quite a powerful tool. The other thing that I really like is this clone button. You're not going to do a lot of these types of inspections once. You're probably going to do them on a regular basis, whether it be monthly, weekly, daily. So you can create a template form or a template project within MerginMaps, clone it, and then use it every time. So you can clone it with a new name. You can say, okay, this is going to be our April inspection. The next month you're going to clone it again. This is going to be our May hydrant inspection. So it's a neat way of being able to keep all your surveys within MerginMaps, replicate them, and then be able to load them back into your application in QGIS. Fun stuff. So if any of this is interesting to you, we are offering a trial offer for people who have attended this webinar series. So this gives you an opportunity to try out an open source GIS. And I always say that I like giving people the opportunity to actually get their hands on this software. If you've never done it before, this is your opportunity. So we're giving 50% off our advanced GIS server for 3 months. We give free basic implementation. But we're also giving 50% off 3 private group training sessions. I leave that quite open-ended because if you have no experience whatsoever with open source GIS, we'll probably start with like intro to QGIS and then maybe do our enterprise course and maybe do something on Geoserver. But if you're fairly advanced, we might just dive into spatial SQL. We might do spatial SQL, Geoserver, and the enterprise course. With this, I like to stay in touch. So I've done this quite a few times where I set up a trial server for an organization. It's nice to stay in touch on a weekly basis. We can have a Q&A session and we can answer some questions during each one of those meetings. But in addition to that, we also offer 10 hours of support. We eat away at this at like 15-minute intervals, but we set you up on our ticketing system. You can submit an email if we need to. We'll jump on a call and help you with problems. So it's really a lot of value for what you're getting and really gives your organizations a chance to really try this software. So if you're interested, the promotion code is spring 2023. You can go over to lunageo.com/servers and check it out. You can email us at contact@lunageo.com, or you can email me at cpatterson@lunageo.com. Send me your expression of interest and we can get you all set up. Probably just start with a little bit of a meeting, figure out exactly what you want to try. If you want to try GeoNode or MerginMaps, or everything that I showed here today, including QGIS and PostGIS, we can have all that set up with you. So any questions? We're just about out of time. None for today. Okay, well, I'd like to thank everybody for coming. It was really nice having a nice showing from the Atlantic provinces. If you do have any questions afterwards, please feel free to reach out. Send me an email at cpatterson@lunageo.com, and I will be happy to answer your questions. Thanks a lot and have a wonderful day.